I'm Josh Sarver, and I'm here with the Phoenix Sideloader NIR instrument by Blue Sun Scientific. The Phoenix Sideloader is a scanning monochromator NIR analyzer that was specially designed for agricultural and food products. Its high throughput and ability to run unattended make it an ideal solution for forage laboratories, seed breeders, and any other labs that would benefit from a high throughput streamlined NIR protocol. The Phoenix Sideloader is compatible with a variety of calibration options, including many customer-owned legacy NIR databases. But its most unique feature is its ability to be paired with an autosampler, as I have set up here. In this video, I'll show you how the Phoenix Sideloader processes samples in manual mode, meaning one at a time, and how it can be set up to run samples automatically. The Phoenix Sideloader uses industry standard ring cups, like this one, which I've already packed with sample. So to begin my analysis, I can place the ring cup on the upper rail of the Phoenix Sideloader here, with the sample cup glass facing the back of the instrument. The BlueScan software has already been set to manual mode, so I only need to select my product type, which is unground canola, give my sample a name, and press scan. Before the Phoenix Sideloader begins scanning the sample cup, it will scan an embedded reference standard. Many NIR instruments do not perform this check before every sample scan, but the Phoenix does to prevent instrument drift over time. Next, the Phoenix Sideloader will guide the ring cup onto an internal carousel, where it will be indexed and scanned multiple times before being fed out onto this lower rail. As soon as the scan is complete, my results will appear on screen. And if I wish to examine the spectra from the scan, I can click the View Spectra tab button here. And that is how you scan a single ring cup on the Phoenix Sideloader. And now I'll show you how the Phoenix Sideloader can be set to run up to 30 samples unattended, or possibly more if samples are added to an ongoing run. To begin, I'll toggle on RFID mode in the BlueScan software. And that's important because all of my sample cups have pre-programmed RFID tags with all of their sample information. This silver sticker is an RFID tag, which is attached to the cardboard backing of each sample cup. The RFID tag contains all of the sample information, including sample name, product type, and any additional sample information. They're small, easy to handle, and reusable. Historically, NIR autosamplers required lists to be programmed into the NIR instrument. While this saved time, it also created problems. If a single cup was misplaced in the sequence, every subsequent cup would be matched with the incorrect information from the list, and the entire run would have to be repeated. Since the Phoenix Autosampler uses RFID tags, and all the sample information is embedded into the tag, it doesn't matter which order they're run in. You can rearrange the order mid-run or add urgent samples to the beginning of the run without disrupting it. So here is a side view of the Phoenix Sideloader, so you can clearly see the autosampler. I have an upper and a lower rail. On the upper rail, which is where samples that haven't been scanned yet sit, I have 10 ring cups, all filled with unground canola samples. The Phoenix is able to analyze a wide range of products. The RFID tag indicates to the Phoenix which product is contained in that specific cup, so it's possible to analyze a variety of different products in the same run. For instance, in the same batch, you could run haylage and corn silage, and the Phoenix would assign the correct product and calibration to each sample based on the information it reads from the RFID tag. Since all of my tags are already programmed, all I have to do is unpause the autosampler, with an easy-to-reach button here on top of the unit, which will begin feeding the cups onto the Phoenix Sideloader sample rail. Then I can press the scan button in the BlueScan software, and the instrument will begin scanning samples and not stop until all of the samples have been processed. After they are scanned, samples are fed down to the lower rail of the autosampler, where they can be retrieved at any time. Additional samples can be added to the upper rail, so you could be running this non-stop throughout the day by continuously adding samples to the upper rail. This autosampler model has a capacity of 30 cups. There is a larger 50-cup model available, depending on the laboratory's needs. The scanned sample results and information are all stored in the software and can be retrieved directly from the scan or history tabs, or exported into LIMS, Excel, or whichever format your lab requires.
Lastly, I'd like to show you how the RFID tags are programmed. As I already mentioned, you can program each RFID tag with the sample number, product type, and other sample information. This small black box is the RFID reader-writer. As you can see, sample cups fit nicely on top of it, always making sure that the sample backing and RFID tag are facing down. The software runs on a standard Windows PC, and you can see here that the RFID reader-writer connects through a USB. I'll begin by reading what is on the sample cup's RFID tag. You may or may not have information already stored on it if you were reusing it from a previous run. It shows that it's empty, and I know that's right. I'm going to program in some sample information now. I'll start with the sample number. Let's call it 1001. When I set up my Phoenix Sideloader, I set canola to have the product code 1. So I'll enter 1 into the product code space. I can, but I don't need to add anything to the sample description space. But if I was using a customer identifier or any kind of barcode management system, I could do it in that space. Then I'll click Write RFID, and my sample cup RFID tag has been successfully programmed. I'll go ahead and do another cup so you can see how quickly this can be done. For the next cup, I'll increment the sample number 1 to 1002. And for the product type, let's pretend it's corn silage. In my Phoenix Sideloader, I have corn silage set to product code 2, so I'll enter a 2 here. Now when the Phoenix Sideloader reads this RFID tag, it'll know to apply the corn silage calibration to this cup scan. Again, I am leaving the sample description blank, so I can now click Write RFID. I can run any combination of products on the Phoenix Sideloader as long as I have the correct databases installed and I match the product code on the RFID tag with the correct product code in the instrument. The Phoenix Sideloader can discern the product, so once I have the RFID tag written, I've sidestepped any potential confusion. And that's it. Programming RFID tags is simple and fast, which complements a very high throughput workflow.
That's a brief overview of how the Phoenix Sideloader operates. If you have any other questions about the Phoenix Sideloader or how to streamline analyses in your own organization, you can find us online at bluesunscientific.com. Thank you so much for watching.